Well, welcome everyone. Thank you for still being here on this last talk of the day. My name is Phil. I'm a software engineer at American Express and also a productivity geek, meaning that I spend more time trying to find ways to do things faster than actually doing things. So today we're going to be talking about Android Studio. And the way these talks usually goes is that you'll have like 40 minutes and try to cram in about 200 tips. Today we're going to talk mainly about three broad subjects, which are Structural Search&Replace, which is a great way to reason about your code and finding stuff while being aware of the Java syntax. External tools, which is a great way to be able to interact with tools that exist outside of your favorite IDE. And live templates, which is a great way to just generate code. So let's start with Structural Search and Replace. But first of all, let's talk about a simple use case as to why you might want to use this in real life. So let's say that you're working on a team and your project has been going on for a while, and one day you realize that you don't really have a really good coding convention. So some people are following the OSP Hungarian style notation, meaning that when they have member variables, they like to prefix all of them with the letter M, and other developers prefer not to have this. So you have a heated debate, and in the end you decide that you don't want these M letters everywhere. This is redundant because anyway, the IDE shows you it's a member variable. The syntax color is different. So you do refactoring, but you want to make sure that you did not forget anything. So how would you go about doing that, validating that you did your work correctly? So the first thing you might want to do is do a find in files for the letter M. So it doesn't really work for obvious reasons. So you might want to try something a bit smarter. Regex might get you part of the way, but it's not perfect. What you would actually want to do is something that could search through the structure of your Java file so that you can say simply letter M, let's say, in fields, or better than just fields starting with the letter M. So actually, this is what something like Structural Search and Replace could be doing. A structural search could do something like this. You press find, and you get simply a list of every field that starts with the letter M. So what is this magic? How does it work? Well, when you use structural search, the way that you're usually building your search query is by mix and matching Java syntax and variables. So the Java syntax is what you would expect. It's just writing an if, and then you have variables that are enclosed in dollar signs, which are pretty much like the capture groups in regular expressions. You can have many different things in your Java syntax. You could be searching only for loops, for if, for enums, for try-catch, for classes, for interface, for pretty much anything. And once you have this syntax done and you are using your variables, you can actually add constraints to these variables to be able to have a more precise search. So a constraint might be, I want this to happen 12 times, or not only once. Or it could be a regex. I absolutely want this field to start with the letter M, followed by an uppercase letter and any other number of fields. So let's see how we'll go about doing this in real life. First of all, you might be wondering, how do I get to structural search? Well, the easiest way is just to use the good old shortcut for find everything, which is Command-Shift-and-A, and start looking for search. It's called search structurally. By default, it doesn't have a shortcut. I created one because I use it a lot. And when you open it the first time, what you're going to see is pretty much a blank canvas. And it could be very daunting when you don't know what to do with it. But the great news is that you don't have to spend 30 minutes looking at the documentation. And the reason is that there is a nice way to learn as you go, which is this beautiful button here called Copy Existing Template. And what it is a collection of a bunch of pre-baked structural search that cover a bunch of use cases. So for example, a bunch of them are class-based, like find all the fields in a class, find all the constructors, all the inner class, and the list goes on and on, enums, try-catch. So when you're trying to use structural search, the best thing to do is try to find something that looks like what you want to do and tweak it. So in our example, there should be something interesting for us. For example, let's see fields of the class. There's a class that occurs once, a field type that occurs at least once but could happen a bunch of times, a field name in it, so like int I equals 0, this would work. So that sounds in our ballpark. Let's do OK, let's just run it. And actually, what we're getting is a single field here. Or if we reopen it, we can see that our scope was the current file. If we look at all the project files, we're gonna have all the fields, which is working for us, just a bit too broad. Let's tweak this a little bit. So, we have our search template, we have our Java syntax, we have fields. What we're looking for is a field name in our case that starts with the letter M and is followed by any number, by one capital letter and any number of letters. So once you have this, you can edit your variables. And I want you to look closely. We have class, field type, field name, and init. When you do edit variable, we still have class, field type, field name, init, and another one for the complete match. So in our case, we would like the field name to start with the letter M, to have a capital letter, and then any number of other character. And just by doing this, if we look at all the fields in our project, we can see that now the only thing that we have left are all the fields that do start with the letter M. And it's only looking at fields. It's not looking at methods. Like for example, I have this weird method that's poorly written. A regex would have thought that this would have been a field. Not there, because structural search understands the structure of Java. We're only looking for fields. So you can inspect your work right now. You know that you have not forgotten anything. But we want to go a step further and make sure that another developer doesn't make the same mistake. And this is where structural search becomes interesting, because it allows you to create some sort of performance lint check. And the way you do this is by adding an inspection. So if you open your settings and you go into the inspections, you're going to see that there is one inspection that is called Structural Search Inspection. And if you activate it and add something, you can see that you can add a search template. If you click this, by default, you'll be greeted by the last search that you made. And what you can do is press OK, enter a good name. So for example, don't use Hungarian notation. Press OK. And now, every time that you use Hungarian notation, you're going to have this warning. So basically, Android Studio or IntelliJ will keep running this structural search and use it as a lint check to make sure that you're not doing something stupid. And it's good enough. But what's interesting here is that it actually creates new files that you can check into source control. So in this case, you're going to see that you have something like SS-based inspection, so like structural search. You're going to see like what you named it and the content. And so what it means is that you can just check this into source control, and all the developers on your team will benefit from this. So this is like the first part of structural search and replace. The second part being replace, right? So what's interesting is that you can use these variables that you've been using as capture group and just to replace something in your code. So again, let's talk about a real-world use case. So let's say that I have a bunch of tags, a bunch of logs in my code right now. And I'm using Android log for now, but I want to switch to this other library that's called Timber. So it's a good library. You can look it up. I just won't go into detail here. The important thing is that the syntax, instead of looking like log.d tag debug message, would look something like timber.d no tag, and then your ebug message, if I was able to type. So it seems like something that could be automated by a computer, right? So let's try to do just that. If you want to replace from one to the other in an automated way, we can use a structural search template and then use a replacement template. So it's a two-part process. First part, doing the search template. So the easiest way to create a search template is going incrementally, because if you try to do it all at once for something complex, you might mess up and try to find why it's not working. So let's do it very simply. So let's copy like the first line, start with our search template, and search only in the current file to keep things simple for us, and do a find. So yeah, that's the first thing. We know we're finding for a simple string. Let's say we want to capture both here. The only difference is that this one has different content. Well, it probably needs a variable. So instead of having your debug message here, let's have a variable and try it again. Now we're capturing both. And one thing you can see that's interesting because it understands Java is that it didn't expect it only to be a string. It expected to be some sort of an expression, a statement. So here we have a string, and there's a string concatenation. So this is something very complex, but this thing doesn't care because it understands Java. So after that, well, we have different method. So let's try to, instead of log.d, go with the method. We're finding everything again. Different tag here, same drill. Let's replace this by tag. And now we should be finding pretty much everything, except this last one. Because if you look at the syntax for logging an exception, it's slightly different. Why? Because you're also logging the exception. So it's a slightly different structure, but we will try to match it anyways. If we were just to say, well, I expect that there could also be an exception here, what's going to happen is that it's going to find it. It does, but it doesn't find anything else anymore. Why? Because the way that structural search works is that when you add a variable, it expects it to be there at least once. It doesn't care what it is. It needs to be there. But this is a behavior that we can change. You can see that we have this edit variable here that we used before. If we edit the variable for the exception, there is another option for the occurrence count. So in our case, we don't want it to be there exactly once. It could be there. It could not be there. We don't care. So let's say it's going to be there 0 or once. And if we try to find it again, now we do find all the occurrences of logs in our file with proper variables that we're going to be able to use for our replacement pattern later on. So now that we have this working, what we can do is structural replace. It's a different shortcut. So when you do your good old Command Shift A, instead of search structurally, it's replace structurally. And it's going to show you this dialog, which is very similar. It's going to start by putting in the previous structural search that you had and provide you with a replacement template. And everything that you see up here, like method and method, is going to be reused. This was the capture group. You can shuffle them around. You can remove them if you want. They're going to be reused. So you have a couple of options. For example, shortened fully qualified class names. When you have those, reformat according to style means that you don't need to care all that much about what your coding standards are right now because it's going to rerun the formatter for you. And using the static import if possible when it does make sense. So let's see how we can do this. We have a log, the method, the tag, the message, the exception. First of all, we want to replace our log by our timber call. So we can just type timber, or you can do the fully qualified class name. And since we've checked the shortened fully qualified names, when we do the replacement, it's just going to show timber.d, for example. But if you don't have timber in your current class, it's going to add the import for you. So it's a bit more magic. There's the method, so timber.d, for example. The tag doesn't exist anymore. And one other particularity is that the exception comes first when there is one, instead of being last. So if we try to run this, it still finds everything. If we preview our replacement, we're going to see that it will try to do timber.log.timber.d with our debug message. And if we do our replacement, well, let's say I should not have had the, now you're just going to put D, which looks a bit weird. So instead, we're just not going to check use static import, and that's why you should not have it in that case. So now if I do my replace all, it's going to do something like timber.d. It puts everything. For the exception, it put it first, and the content of the exception. And what's really interesting is that since this thing understands the structure of Java, if there is an exception, it's going to put it there. If there's not, it's not going to put there. But you don't have to tell it, like, don't put the comma in front, for example. It just knows what to do. And again, the other nice thing that you can do is make sure that the other developers don't use the regular logs anymore. So what you can still do is go into the inspections in your structural search inspection, and now you can add a replacement template. It's still going to provide you with the previous one. You press OK, use timber. And now what's going to happen is that not only is it highlighted as an error, but if you do a good old Alt-Enter on it, it's going to run the inspection, and then you have the quick fix, and you know what you have to do. So it's still checked into source control. Everybody on your team can use it. So that's pretty much it for structural search and replace. So this is a good way to reason about your code. Try to find something by knowing what the structure of Java is to make some interesting, safe refactorings. It works in Java. It works for XML. It doesn't work yet for Kotlin. Hopefully it will at some point. All right. Second thing I'd like to talk about, external tools. What are external tools? Anything that you use that's not part of Android Studio or IntelliJ. So that could be like Photoshop, Pixelmator, Atom, a command line tool like ls, whatever it is that you want to use. And why would you want to use this? Basically, it allows you to do interesting things like give the current context of your IDE to another tool. So for example, one of the interesting use cases is to generate open with commands. So for example, if I want to open my README with Atom, I could have an external tool that just open with that's going to open it in another tool. So for example, you want to edit an image in Photoshop instead of opening like Preview on the Mac. You can do something interesting with this. So how does this thing work? You can create external tools, pass these tools a simple context. So you give them a name, you give them a group where they will appear, you give the tool a path, the tool path, and then you can pass in macros. And macros are replacement that looks pretty much like what we had with structural search and replace, but instead of being used to match stuff, they are used to generate something. So for example, in Atom, what you would pass is the current file path, for example. You have different type of macros that you could be using. So you can show, for example, a prompt to a user. So you could use this, for example, to do like ADB input shell text when you want to type a password real quick. You could be using this to open a file in another program. You could right-click on an APK, say use ADB install at this point. You could even like just mess up with your coworkers and create an external tool that just says something using the say command and bind it to their run configuration. There are a couple of possibilities. So how do we end up doing this? Well, let's say that my use case right now is that I want to be able to once in a while open the current folder in iTerm instead of opening it inside of Finder. Well, if you just want the terminal, there's one built in to Android Studio. If you do like Alt F12, you're going to have a terminal. But let's say that you want to really be able to use iTerm instead. What you can do is open the preferences and search for tools. And you're going to see that somewhere down there, there is external tools with, let's say, iTerm or Atom, Pixelmator. You're going to, by default, you will have absolutely nothing. Once you get there, you'll be able to create groups. So let's kill iTerm and do it again. So first thing you do, you add a tool, you give it a name. Let's say iTerm. You can assign it a group. In my case, it's going to be OpenWidth. You have a couple of options depending on what the tool that you are using will be doing. So for example, if the tool that you are running is going to modify files that your project depends on, you might want to synchronize the files after execution to make sure that the IDE picks up everything. If there is a command line part, like a result that you want to see, it can open a console, or you could also tell it to just show the console when a message is printed or an error is printed. Then you can decide where you want to be able to invoke this tool. Usually it's pretty much everywhere. And then the meat and potatoes, what are you doing and what are the parameters? So in our case, let's say you want to open iTerm. We know that it's going to be in applications, and it's going to be somewhere like right here. And we want to pass a parameter to our app. So there is this insert macro button where we have a bunch of different macros that we could be using at this point. And the nice thing is that you don't have to try to infer what they should be doing. The name is pretty much self-explanatory, but what's really interesting is that once you click on one of those, you have a preview of what it would look like for the current file. So you know when you're like, you don't know if is it just the file name, is it the file path, does it include a folder, what is it? You can see it pretty easily. So for example, like here's the file directory, that makes a lot of sense. You could have the file path. So in our case, let's just do the file path. So if I use this tool, I press OK. Now what's happening is that I can right-click on a folder and do open with, and for example, iTerm. And it's going to open it at the correct place. Or I could go a step further, actually. I would like to be able to click on any files and be able to open the current folder. So what we can do is create scripts and invoke those scripts from external tools. So for example, in my case here, I do have one script that is called iTerm. And well, it's a shell script. I don't have a shell plugin in Studio, so it looks bad. But when you have external tools configured, you can actually also call them using either shortcut that you've defined yourself or with the good old Command-Shift-A. So if I just want to open this script with Atom because it's going to look better, I can just do this. I'm going to see it. I do my modification or inspect my file, and then I'm back to doing what I wanted to do before. So the script is pretty easy. It just takes the argument. If it's a directory, it opens it. If it's a file, it takes the base directory and opens it instead. And otherwise, it just shows that something went awfully wrong. So let's go back to our external tools. And now, instead of iTerm, what we can do is call a script. And it's going to take the current file path, which is going to be either a file or a directory. Press OK. And now if I'm here, I can still do something like just call iTerm. It's going to say the argument was a file, opening it, and does it. Or if I was in a directory, this thing would still work. You can do an open with, iTerm. It's going to print something. And then there you have it. So basically, external tools, a very easy concept. You can just open something outside of your IDE, but with giving some sort of a context. My best use case is in the open with. There are other contexts, for sure. The other great feature I want to talk about today is simply the live templates. So what are live templates? Live templates are a great way to be able to generate code inside of your IDE, but with knowing a little bit about the current context. So it's not simply having code snippets. It's something that understands its surrounding. So for one example would be the built-in live templates in Studio. So for example, one of the provided live templates is log_t, which is simply going to create the log tag. Or another one could be log_d, which would be generating a debug log. And they might look like simple snippet expansion, but actually what's interesting is that you can pass in some methods to this so that you can have a behavior that understands its surroundings. So for example, if you look here at the tag that was generated, by default, it pre-filled the value to live templates, which is the name of the class. So it means that when you are generating your live template, you can pass it a method that is, give me the class name. Or in the case of the debug log, what you can see here is that it added the name of the method right now. So you can generate code really quickly with understanding the surrounding context. So the way that it works is, then again, you write your Java code with your fully qualified class names, your methods, whatever you need. And after that, what you can use are variables. And these variables will be either expanded using different methods that are built in Studio, or will simply serve as placeholders so that you can type your code. These methods can be edited in a dialog, and like I said, a bunch of different expressions you pass there, like the method name, the class name, the date, the name of the current developers if you want to generate like headers in your comments, stuff like this. So let's take a look at how these things work. Let's take a look at how we are actually using live templates. The easiest way to use live templates is once you start knowing what the abbreviation are, is that you can just start typing them and pressing tab, and they're getting expanded. Otherwise, you can go with like Command J and try to find as you type. And there are a bunch of those that are already built in, like very simple one like this, some that are a bit crazier, like log m, which is going to take like the name of the method and then try to expand each and every parameter that you have in a very nice logging string. But let's try to see how we could build our own. So the easiest way to build your own live template is actually writing the code yourself and then saving it as a live template. So let's say, for example, that what you want to do is create, instead of log D, like a timber log, like TD. So what you would do would be type what you want to extract. For example, timber D, like my message. And once you get the snippets that you want to use afterwards, you can highlight it, you can go to Tools, and there's this option called Save as a Live Template. And when you click this, it's going to get you to the live template screen. You'll be able to give an abbreviation for the quick expansion. You're going to see that it puts in the fully qualified class names. So that way, when you use this live template in a class that did not have the classes that you want to expand with this, it's going to add the import automatically for you. And now what you can do is add variables. So of course you don't want to expand to my message. You probably want to expand to something like some random message. And if you press OK here, the next time you type TD, it's going to appear, press tab, and you're going to be able to start typing. But we can go a step further than that. If you go back to the live templates, here, first of all, probably we want to put this inside of double quotes so we don't have to type these double quotes. But I also like to have the surrounding method name because it's going to help me when I do my log. So if I want to add the method name, what I could be doing is adding another variable. For example, the method name, add a colon. And we do have an edit variable button here that we can use. And when we get here, what we can do is pick among a variety of built-in methods that exist inside of IntelliJ and Studio. So for example, it could be all the variables from an array that are already there, or the class name. You could trigger the auto-completion at that point. In our case, what we're looking for really is the current method name. Let's press OK. Let's use this method name. So now what we can do is, again, TD is going to pre-fill the method name. When you press Enter, you're going to be able to type your message. When you press Enter again, you are at the end of your live template. So these things seem small, but in time, usually those are little shortcuts that help you. We could get it a bit better still. So for example, if I type TD, it asks me if I want to change the name of the method. Doesn't make much sense, so let's remove that. What you can do inside of your method, of your variables, is check this, which is skip if defined. So if the method that you're calling resolves to something else, it's something that's not empty or null, it's just not going to ask you to do it. So then again, timberD, do something, message, and we are done. So these are very simple live templates that you can do. These are one-liners. They can get more complicated than that if you need to. Another type of live templates that is pretty useful is the good old surround with live template. So what you can do with the surround with is when you have a selection, you can invoke a surround with and surround it with something else. For example, an if statement, put it in a runnable, put it in a lambda, put it in action one, put it in whatever you want. So The way that you are able to use this is by doing Command-Shift-A, looking for surround with, or the shortcut, which is Command-Alt and T. And the thing is, they're pretty easy to use, and they're pretty much as easy to write. So let's say, for example, that you do not have something to create a runnable. How we go about creating a surround with template for a runnable. The way you would start this is, as always, just try to write the code once and then extract it. So for example, I'd like to have a new runnable, something like this, and do something. So once you have your code, you can again select it, go to Tools, save it as a live template, and give it an abbreviation, even though in this case it's a bit harder to use because you cannot like type it and expand it. You would remove your selection. So let's call it my runnable. The way to mark it as a surround with live template is by using a reserved keyword, a reserved variable. So there is this variable that is called selection. You can see that you cannot edit it, and the only thing that it does, it says replace this variable by the current selection. So, and at the same time, it marks it as a surround with live template. So if I do this, and I say something like test, I will have my runnable here that I can call, and it's gonna surround it with my surround with template. So it puts my cursor at the beginning, which is not ideal in my case. I prefer, depending on the case, to be able to have it at the end so that I can put like my semicolon or just go elsewhere. So there's also this option with template. So there's another reserved keyword that is called end. And the only thing that this thing is going to do is tell IntelliJ or Studio where to put the cursor when the template is expanded, when you're done replacing everything. So if you press OK at this point, and we do it again, what you can do is my runnable, and it is at the end. So it's another tool in your arsenal, regular live templates and surround with live templates. A couple interesting thing about live templates. First of all, they are local to your machine. So that means that they are not checked into source control like, for example, the structural search and replace was. But all hope is not lost. When you are in your live templates, what you can do is copy-paste them. And what's interesting is that it's not like just copying it like a big blob locally. It's actually putting XML inside of your clipboard that you can use. So for example, here, I've copied my template. You can see that it's an XML that can be reused. So you could be pasting this through Slack or sending an email or even keeping a file locally in your folder so that your other teammates are able to benefit from your live templates. Another crazy feature from live templates is that you can actually inject GroovyScript right in your live templates if you want to have more computing power. So I was speaking earlier about this log m template made by the studio team, where it's able to take like the parameters and then expand a string so that you can log the parameters and their value. If you look at how this thing is implemented in Android log and log m, it looks simple enough, but when you look at the variable itself, you're going to see that it's actually calling a simple but daunting GroovyScript if you're not used to Groovy. So let's take a look at about how this thing is implemented. So first of all, let's copy it elsewhere because it's really hard to see here. Let's create a Scratch file. So if you never use Scratch file, those are basically files that are not saved on disk that do have syntax highlighting, but that don't really allow you to run anything. So let's say I'm starting a Groovy Scratch file and I paste it. What you're going to see is that we have two methods that come from the live template. So for example, the method parameters and the method name. And we have a string. that's the Groovy script that we're running. So the Groovy script is a bit hard to read in there just because everything is escaped. So another nice feature inside of Studio is that you can treat any string as containing another language. So if you right-click on it, you have an option to inject a language or a reference. So language could be Groovy, could be, for example, JSON. If you're writing your unit test or instrumentation test and you want to be able to have JSON write in a string, you can use this thing so that you don't have to bother about escaping. So in our case, let's say it's a Groovy file. It doesn't change much, but what's interesting now is that if I Alt-Enter on it, I have this Edit Groovy Fragment option that appears. And now I can edit this code in another virtual editor that will escape everything properly. So for example, if I was to add a couple of double quotes here, you can see right above that everything was escaped properly. So if you look at the Groovy script in use in live templates, what you're going to see is that you have a couple of underscore methods, like _2 and _1. And what these are simply the parameters that were passed to the Groovy script live template. So in our case, the method name and the method parameters. So you can have as many parameters as you want inside of your Groovy script. And there will be named like _1, _2, up to _n, and whatever that you want to have. So what this Groovy script is doing is taking the method parameters, it's collecting it, which is pretty much mapping it, and it's creating the string that we've seen earlier to do the log. It's joining it using a simple comma, and after that, it's taking everything, it's putting like the method name in front, this parameter list, and then it returns. So you can put very powerful things in there. The only thing that you need to know is that the script is invoked every time you type a character inside of your live templates. So please don't start like doing network requests or blocking anything because it's going to block pretty much everything. Last thing that we can talk about here is how can you get better at live templates and understand what you could be doing. Well, the easiest way is pretty much to take a look at what already exists. So we were talking about the Android logs or how to generate runnable. There's even one to create, let's say, a parcelable. The interesting thing is that none of this is black magic. None of this is hard-coded inside of IntelliJ. Everything is available right here, and they are editable. So when you are looking at what can I be doing, just sift through pretty much the live templates that already exist, get inspired, and try to do something of your own. And so that being said, I think I'm slightly out of time, or pretty much right on it. So if anyone has any question, I think I can take like one or two, and after that, just come and see me. Thank you very much.